Okay, students, so this is page 117. Now we're going to be doing, still in linear regression, but now we're going to be doing a hypothesis test for the population beta, which is the slope of the equation of the line. So you test to see if the slope is 0, that's your assumption, that's your H0, meaning if the slope is 0, there's no relationship going on, versus the alternative that the slope is negative or positive or either one, indicating some sort of relationship. We're also going to be doing a confidence interval for beta to try to estimate what it is. Now, an 89 titanium can do a beta test and a beta interval. The 83 and 84 graphers, I'm trying to remember, I don't believe they do a beta test, but I believe they do a beta interval. See my calculator aids videos to double check that. We're going to be proceeding by hand for all of you old school people out there. Okay, so we've got example 10.6 on page 118. Now we need to recall from the data that the little b was 7.67603. The standard error of estimate was this, and the sum of the x squareds, as well as the sum of the x's, because we need those for our formulas. So let's get started. We want to have a 1% level of significance, and we want to test the claim that the population slope is positive, meaning a positive correlation going on. So H0 is our null hypothesis. We always assume that the slope is 0, meaning no relationship, no correlation, versus the alternative in this case, that there is a positive correlation happening, beta greater than 0. Step 2 is to look up a critical value. It's going to be a t of 1% level of significance with 5 minus 2 degrees of freedom. So if you look that up on your table, it's a one-tailed test. You're going to have 4.541 as your critical value. Draw the line, shade your rejection region. So we're going to plot our critical value, shading our tail, and labeling it as a rejection region for those of you who are doing the critical value method. Now your test statistic is a little bit icky, but that's okay. Take it very slowly and it should be fine. It's the sample B, sample slope, which is 7.67603 all over the standard error of estimate, which is 7.38969, which is what we're using, times the square root of the sum of the x squareds, that's 103.84, minus 1 over n, so that's 1 over 5, times the sum of the x's, 21.4 parentheses squared. Now watch your calculations in this. Make sure that your calculator knows to do everything in here under the square root. Make sure it knows that 1/5 is a fraction and all that good stuff. You should be getting a test statistic of 3.63532. Now you look to see where your test statistic falls in your rejection region picture. It does not fall in the rejection region, so we will fail to reject H0 in step 4, our decision step. Our conclusion is based on the evidence the population slope, since we're failing to reject H0, we will say the population slope is not greater than 0. I should have left myself a little bit more room there. At alpha equals 0.01, which indicates no significant positive correlation, okay, between x and y. So based on the evidence, there's not a positive correlation between x and y. We don't know if there's a negative correlation because we didn't test for that. We don't know if there's you know, you can't just say, oh, well, it's not positive, so it must be 0. So we just have to talk about, you always have to talk about the alternative. Remember that in your conclusions. Let's hop down here and do a 95% confidence interval. Now on your t critical value, you're going to get this from the t table, but now you want a 95% confidence. So you're going to be looking at that C row instead. And so your t critical value is going to be 3.182, and that comes from looking at the C row and going down 3 degrees of freedom. Okay? Remember to always look back on your theory pages to find out where I get those interesting numbers and all that kind of stuff. Okay? SE, well, we copied that down earlier. That's 7.38969 times 1 over, it's going to get messy, sum of the x's squareds, 103.84, times 1/5 times 21.4 parentheses squared. And again, you're going to have to really watch your calculations. If you do everything correctly, you should be getting 6.71883. By the end of this course, which is where you are at currently, if you're watching this video, you're almost done with the semester. You should be master calculators by now, so I shouldn't have to coach you through the order of operations of mathematics. Once you get your error of tolerance, you're going to use your sample B, your sample slope, which was 7.67603, and you're going to subtract off that error of tolerance, 6.71883, less than big beta, less than the slope again, 7.67603, plus the error of tolerance. And you should be getting an interval that's approximately 0.9572 on the left-hand side, and on the right-hand side about 14.3949. And you're going to say, based on the evidence, we are 95% confident that for every unit change in the x variable, whatever it happens to be, the y variable, whatever that happens to be, again, if you know descriptive names, use them. I'm not using them in this scenario because I don't remember what they were or if they were even available. But it's between 0.9572 and 14.3949, which indicates a positive slope, or at least we're 95% confident that there was. However, in our hypothesis test, with a 1% level of significance, we found that it was not significantly greater than 0. Here we're using 95% confident, so if you were to do a hypothesis test that directly correlates with this confidence interval, your alpha would be 0.05. So keep that in mind. Here alpha is 0.01, so a confidence interval that we would be using would be a tighter interval, which would be, or it would be a wider interval, because you would be 99% confident. So here we're indicating that we're 95% confident that the slope is positive, but it might be a really small positive slope, like the 0.9572. But anyway, those are the steps. 3-step process for the confidence intervals, 5-step process for the hypothesis test. And that is pretty much all we get to do in linear regression for the semester. The next videos that I'm going to have after this lecture video will be primarily working with the TI-83 and 84 plus calculators. Now, if you want to know how to use all the different calculators that we use, check out the calculator aids videos.